Today we're going to look at some examples from lessons 2.7 and 2.8. So we're going to once again apply the transitive property as well as recognize vertical angles. So here we have an example where if we look at the picture, we're told that angle 1 is congruent to angle 2. So I'm going to mark that in my picture. Angle 1 and angle 2 have the same markings. We're also told that angle 2 is congruent to angle 3. So because angle 2 already has a marking, that's how I get to mark angle 3. What we want to do now is we want to decide on what our conclusion would be, and then we're going to justify that with a reason. So if we're looking at the picture and how we have it marked up, hopefully we notice that, hey, they all seem to have the same markings. Notice that angle 2 is a common link right here. That's why all of them share the same markings. So when you have that common link, that means that angle 1 is congruent to angle 3, and our justification would be the transitive property. So once again, anytime we have that common link, we're going to have congruent pieces because of the transitive property. Let's look at this. We are given that the segment GJ, so this segment right here, I'm going to give it 1 tick mark. That's congruent to the segment HK. So that gets 1 tick mark. That's the only thing that we know. We want to come up with a conclusion and then a reason to justify that conclusion. So anytime we are given a set of congruent pieces, what I notice about this picture is that there happens to be a place where those two congruent segments overlap. Notice that this segment of HJ is shared between the two congruent pieces. And so when that is shared, think about it. If I was to remove what those two have in common, it's going to leave me with this segment of GH, and it's going to leave me with this segment of JK. If those two big segments are congruent and we take away the same amount from both, hopefully you're okay with the conclusion that the segment GH is going to have to be congruent to the segment JK. And how did we go from something big, which was given, to something small that we concluded? Well, to go from something big to something small, that would be the subtraction property. So just to kind of justify that, notice that the big piece was the segment GJ, and I subtracted away the segment, HJ. That's what made equal then the original big segments of HK minus the same exact piece that got taken away, HJ. So there's my justification. To go from something big to something small, we are subtracting. So subtraction property. So I'm going to give you a second. If you see that the given information says the diagram as shown, so if you're just looking at a diagram, what kind of conclusion can you draw? And you need to justify it with a reason. So pause the video for a second and see what you can come up with. Hopefully you paused it and hopefully you looked at it. And so because we are trying to figure out, well, what can you assume? I'm giving you in this picture angle 1 and angle 3. Notice that those two angles share a vertex and they're directly across from each other. That makes them vertical angles. And so remember, that means that angle 1 is congruent to angle 3 because vertical angles are congruent. All right, let's take a look at this example. So we're trying to solve for both x and y. So given this picture, we have to think about what can we assume from it. Okay, notice that in this picture, I have some vertical angles, two of which, this angle and this angle, have something that represents that. So vertical angles are congruent. One of my equations is that x plus 2y is going to have to equal 50. Because there are two variables in that equation, we have to come up with a second equation in order to set up a system which will then allow us to find our variables. So we can't assume anything else is congruent. However, what we can assume about angles are that we have some straight angles. So there are actually several straight angles in this picture, one of which I'm highlighting right here. So the angle that I just highlighted is made up of two angles. So put those two angles together, they have to equal 180. So my second equation is x plus 2y plus x minus 2y is going to have to equal 180. So here's my system. I'm going to go ahead and start simplifying the bottom equation because it looks like the top equation, there's nothing that I can simplify. So I'll still have x plus 2y equals 50. But if I look at the bottom, notice that the 2y and the negative 2y cancel. So that gives us then 2x to equal 180. So technically then I don't really have to do any substitution or elimination. That bottom equation is going to allow us to solve for x right away. I'll divide both sides by 2. And so 180 divided by 2 tells us that we get a value of x to be 90. So now I can go back to this equation right here that contained the y. I can substitute 90 in for x and I can solve. So we're going to have 90 plus 2y equals 50. I'll subtract 90 from both sides. That gives us 2y to equal negative 40. And then I'll divide by 2 and we get a value of y to be negative 20. So even though the y value is negative, I just want to pay attention to this really quick. If I was to plug these numbers back into the angles, we never want to have negative angles. So it would be a good idea to kind of maybe go back and double check that, because even though we have some numbers that are positive and some numbers that are negative, we want to have only positive angles for our final answer. So if I was to plug that in, the x plus 2y, because x is 90, if I multiply 2 times negative 20, that would tell me that I would have 90 minus 40. So that would give me 50 degrees. And so that checks out. 50 is a positive number. If I plugged those numbers into this other angle right here, we would have 90 minus, and then 2 times negative 20 is negative 40. So we'd have back-to-back negatives, which would really turn that to addition. That gives us 130. So it checks out because 50 plus 130 is going to give us 180. And notice that it also checks out because we got 50 degrees right here. Well, 50 degrees is here. Vertical angles, they're congruent. That's how it should have been. Okay, so even though my value for y happened to be negative, the angle was still positive. But just be careful. Sometimes people will get negative numbers and then not double check, and you'll have a negative angle. And then that's the key right there to be like, oh, hey, I made a mistake. I can't have a negative angle value. So just be aware of that. Let's look at this problem. We've got that the ray BD bisects angle ABC. So angle ABC is this angle right here. To bisect means to divide into two equal pieces. Well, notice that angle ABD is already marked. So I get to mark that angle of DBC exactly the same. So notice that because those two are congruent, I can set up an equation that x minus 2y has to equal y. The only issue is because there are two variables in that equation, we have to come up with another equation. Notice that my picture showed that originally that angle of ABD was equal or congruent to the angle BCD. So I'm going to set those to equal. So x minus 2y is going to equal 124 minus x. So now that I have my two equations, I'm going to start rearranging the terms. We can figure out if we want to do substitution or elimination. So I think I'm actually going to do substitution in this, because on the top, I'm going to add the 2y over to the other side. And so that's going to give me x to equal 3y. If I look at the bottom equation, I'm going to move that x over to the other side. So then that gives us 2x minus 2y to equal 124. And so I can do substitution because I've got a variable of x by itself. So I'm going to take what x equals, which is 3y, and I'm going to substitute it into the x in that other equation. So we're going to have 2 times 3y minus 2y to equal 124. So that will give us 6y minus 2y to equal 124. Subtract, we'll get 4y to equal 124. And then we'll divide by 4 to get a value of y to be 31. So there's one of our answers. So then I can solve for x by going back to the equation where x equals 3y. So plug in 31 for y, and x is going to equal 3 times 31, which is 93. Once again, it'd probably be a good idea to then go back and double check. If I plugged in 31 for y and 93 in for x, am I going to get angles that are positive? So if I plugged that in up here, 93 minus 2 times 31, well, 2 times 31 is 62. 62 is smaller than 93, so that will give me a positive angle. Obviously, plugging in 31 here is going to stay positive, so that checks out. If I plug x in over here, well, 124 minus 93, I'm going to get a positive number. So we're good. All right, if we look at this word problem, it says when 1/2 the supplement of an angle is added to the complement of the angle, the sum is 120 degrees. We're going to find the measure of the complement. So anytime we're talking word problems dealing with supplements and complements, remember, I always let x equal my angle. So whatever that angle is, I know that to find the complement, we have to do 90 minus x, because remember, two angles add up to 90 are complementary. So if I already know one of the angles, I'm subtracting it from 90 to get the other. When we're talking about supplementary angles, two angles add up to 180. So once again, if I know that one of my angles is x, 180 minus x is going to get me the supplement. So now that I know what my angle, my complement, and my supplement represent, I'm going to go back to the word problem and substitute in what I know. So 1/2 the supplement of an angle. So 1/2, and then be careful, the supplement is 180 minus x. So make sure that that's in parentheses so 1/2 gets multiplied to the whole thing. So when that is added to the complement of the angle, so added means addition, complement of the angle would be 90 minus x. The sum is means equals, and it equals 120 degrees. I'm going to distribute the 1/2 to get rid of the parentheses. So half of 180 is 90, and half of a negative x is a negative 1/2 x. We're not going to distribute that to the 90 minus x because there was no parenthesis. I'm going to start combining. 90 and 90 is 180. And negative 1/2 minus 1 is going to be negative 1.5. And there's an x with that. Another way you can think of that is negative 1.5. So I'm going to probably change it to that decimal in a second. I'm going to move the 180 over to the other side. So we'll have negative 1.5 x, and that's going to equal negative 60. So I'm going to divide by negative 1.5, and that's going to give me my value. So let me get my calculator. So if we have negative 60 divided by negative 1.5, that tells us that x is now positive, it's 40. So my angle is 40 degrees. However, if we read the problem, it wants us to find the measure of the complement. So we know that the complement, once again, is 90 minus whatever the value of x was. So since we got x to be 40, 90 minus 40 tells us that our angle is a 50-degree angle. And that is us applying the transitive properties as well as recognizing vertical angles.